Students, very good morning. Today we want to teach modern physics. So before going to discuss about modern physics, what is modern physics? Modern physics, what is modern physics? It is a branch of physics which deals with the, it is a branch of physics which deals with the microscopic objects like atomic particles and nuclear particles. And what? Nuclear particles. So whereas the another physics, that is the classical physics, that is ancient physics. In ancient physics, it is a branch of physics which deals with the macroscopic objects like Earth, Moon, planets, satellites, asteroids, like that. So especially in this modern physics, in our CBSE, what we have? In this modern physics, we have three parts. One is dual nature of radiation and matter. Dual nature of radiation and matter. Another one is atoms, that is atomic physics. Okay now. So another one is nuclei. This is nuclear physics. And another one is electronics. This electronics is also in modern physics. So now our present topic is what? Dual nature of radiation and matter. Dual nature of what? Radiation and matter. So do you understand the word dual nature of radiation and matter? That indicates radiation has a dual nature and matter has a dual nature. We have to prove radiation has a dual nature, matter has a dual nature. That indicates radiation behaves like a particle in wave nature, matter behaves like a particle in wave nature. So that's we have to prove from this lesson. So before we are going to discuss about dual nature of radiation and matter, what is radiation and what is matter? Okay, radiation is nothing but emission. What is radiation or emission means? The process of producing of electrons. Producing of what? Electrons from the metal surface. The producing of what? The production of electrons. Production of what? Electrons from the metal surface. Suppose we take a metal. Okay, now from this metal we have to produce some electrons. So is it possible by normal methods? It is not possible. We can get the electrons from experimental techniques. Okay, now easily can we get some electrons from metal rod? It is not possible. So that indicates some work we have to do it. So the production of electrons on the metal surface is radiation or emission. Okay. The ejection of electrons also, production of electrons from the metal surface, or the ejection of electrons. From the metal surface. Also called as radiation. Especially this radiation is of three types. Radiation or emission is of three types. So this radiation is called, we can get electrons now. So this radiation is also called as electron emission or electron radiation. Electron emission or electron radiation. So ultimately we can get electrons from the metals. That is so, it is called electron emission. This electron emission is of three types. One is thermionic emission. Thermionic emission. Thermionic emission. Another one is field emission. Field emission. Another one is photoelectric emission. Photoelectric emission. Understand? These are the three types of emission. Electron emission have three types: thermionic emission, field emission, photoelectric emission. So individually, what is thermionic emission? What is field emission? What is photoelectric emission? That we have to see. All of you understand? Students, all of you understand?
Yes, sir. Yes, yes, sir. Yes, sir.
Okay. Finish it?
Completed, sir.
So now we are going to discuss about thermionic emission. Thermionic emission. Thermionic emission. What is thermionic emission? The name itself, thermionic. Thermionic means, therm means heat. So by heating the metal surface up to suitable temperature, the rejection of electrons takes place. Is called what? Thermionic emission. By heating the metal surfaces, by heating the metal surfaces, comma, up to suitable temperature, at suitable temperature, then ejection of electrons takes place. Ejection of electrons takes place. Such type of emission is called what? Thermionic emission. Thermionic emission means by heating metal surfaces, to heat the metal surfaces up to certain temperature, the rejection of electrons takes place. Such type of emission is called thermionic emission. Right? Next, field emission. Field emission. Field. Field means there are two types of fields will be there. Not only two types, three types of fields will be there. Electric field, magnetic field, and gravitational field. Here, by applying strong electric field, applying strong electric field. So applying strong electric field means up to what, sir? Nearly 10 to the power of 6 volt by meter. 6 volt by meter means if we are taking 1 meter of rod, 1 meter metal of rod, we are applying 10 to the power of 6 volt potential. The rejection of electrons takes place. Such type of emission is called field emission. By applying strong electric field to produce electrons from metal surface. To produce electrons from metal surface. This is called field emission. Clear? Next, a very, very important topic, photoelectric emission. Photoelectric emission. Actually, generally, dual nature of radiation matter is nothing but photoelectric emission only. In this chapter, mainly we will discuss about what is photoelectric effect and applications of photoelectric effect. That is the main thing in this photoelectric emission. Okay. So photoelectric emission. What is photoelectric emission? When a certain frequency of ultraviolet radiation, certain frequency of ultraviolet radiation is incident on the metal surface, Okay, so in thermionic emission, by heating the metal surfaces. In field emission, by applying strong electric field. Whereas in photoelectric emission, a certain frequency of ultraviolet radiation is on the metal surface. Then ejection of electrons takes place. Right? Such type of emission is called photoelectric emission. Okay, these ejected electrons are called photoelectrons. So finally, this phenomenon is known as photoelectric effect. This phenomenon is known as photoelectric effect. Very, very important. This is the main topic. So actually, generally, so many teachers start that dual nature of matter and radiation, nothing but they will start with photoelectric effect. But these all things is important. This is in the CBSE part only. Thermionic emission, field emission, photoelectric emission. Right? All of you understand? Students, any doubt?
Yes, sir.
Any doubt?
No, sir.
All of you?
Yes, sir.
Okay? Completed? Completed? Now, What is photoelectric effect? Photoelectric effect. Photoelectric effect means the ejection of electrons. The ejection of electrons when sudden frequency of ultraviolet radiation is incident on the metal surface. This is called photoelectric effect. So is it possible to eject the electrons by using metal surface normally? So we have to do some work. So what type of work we are doing to get the electrons from the metal surface? Okay now. So now before we are going to discuss about photoelectric effect applications, the terms regarding photoelectric effect, the terminology regarding photoelectric effect. Terminology regarding photoelectric effect. Okay, what's the terminology regarding photoelectric effect? So while we are reading photoelectric effect, what are the terms we have to use? One is work function. Work function. This is denoted as W or phi. Second one is threshold frequency. Threshold frequency. This is denoted as nu naught. Threshold wavelength. Threshold wavelength. This is lambda naught. Stopping potential. Stopping potential. This is V naught. Right? This is the terminology regarding photoelectric effect. Work function, threshold frequency, threshold wavelength, stopping potential. So what is work function? What is work function? The name itself, work function. Work means energy. Work is a form of energy. Okay, now what type of work you have to do here? So photoelectric effect is nothing but the ejection of electrons takes place on the metal surface. So here work function means the minimum amount of energy, the minimum amount of energy, the minimum amount of energy required to remove, the minimum amount of energy required to remove an electron from the metal surface. Electron from the metal surface. Are you understand what is work function? The minimum amount of energy required to remove an electron from the metal surface, because we have to get an electron from the metal surface. So in that case we have to do some work. So that is energy. The minimum amount of energy required to remove an electron from the metal surface is called work function. Is called work function. That indicates to get the electrons from the metals, we have to get the different work function for the different metals. Because some metals we have to apply, we have to consume more energy. For some metals we have to consume less energy. So the different metals having different work function. So different metals having different work functions. Different work functions. Okay. So generally work function is energy. So to get the electrons now, work function W is equals to H nu naught. Mathematical formula W is equals to H nu naught, where H is Planck's constant. H is Planck's constant. 6.6 into 10 to the power of 6.625 into 10 to the power of minus 34 joule second. This is W naught. Generally work function measured in W is measured in electron volt. So I will tell you what is electron volt. Okay now. So different metals having different work functions. So this work function depends on nature of the metal surface. Work function depends on nature of the metal surface. Nature of the metal surface. Because different metals having different work function. So nature, depending upon nature, the work function also depends. So, okay. All of you understand, students? Hello, students.
Yes, sir. Yes, sir. Yes, sir.
Okay. So, what is electron volt? Electron volt. Electron volt. EV. Electron volt means electron volt is the unit of energy. The energy gained by electron, the energy gained by an electron, energy gained by an electron when it is accelerated, accelerated through 1 volt of potential difference. 1 volt of potential difference. So that is called electron volt. What is electron volt? The energy gained by electron. When does electron gain some energy? When does it is accelerated to a potential of 1 volt. Accelerated to 1 volt of potential difference. So W is equals to, as we know that V is equals to W by Q. V is electric potential. What is electric potential? The amount of work done to bring a unit positive charge from infinity to certain point against to the electric field is called electric potential. So V is equals to W by Q. W is equals to what? VQ. Here W is equals to what? VQ. Okay. So Q means charge of electron. So EV. W is equals to EV. Right? Electron volt. So generally W is equals to VQ means 1 volt is equals to 1 joule by 1 coulomb. 1 joule by 1 coulomb into 1 coulomb means 1.6 into 10 to the power of minus 19 electrons charge.